Hello, everybody. Happy Monday evening. This is the evening where we like to have our live streams, and you are going to be in for a treat this one. This live stream is one we've never done before, and I'm very excited about it. So, tonight, I will be your host. My name is Tiffany Hall. You may have seen me around. I'm an alumni of the TripleTen software engineering program. I'm also currently a full stack engineer at Scholastic Inc., the world's largest publisher of children's books and a powerhouse in the digital education space also. Um, Tonight with digital, our data science code pudding, there's a lot of things there. With our data science code pudding, we've never done this side of the data science house, and so I'm very excited. We are doing a code pudding, which has been a really wonderful short time frame competition for all of our students to get together across the US. If you're not familiar with our code puddings or maybe our code jams are a little more involved. And they usually are something that is very robust and large and teams of very large people, and we're moving mountains. Whereas code puddings are like a delightful little treat, kind of the sweet treat at the end of a meal. Another fun one is that they're putting in the work on the learning in the project. Okay. So the code pudding tonight is going to be a super short competition. These students have only had 4 days to get together and work on their project. And the project that I'm going to talk about tonight is the first of its kind. I'm very excited and I just can't wait. So we have divided our teams into 3 teams, and these teams were challenged to collaboratively build a machine learning model that will be used to predict the genre of a song. So I'm very excited about that. We have 2 parts. They're going to show us the data that they've been working with, building up the model, kind of working through those pieces. And tonight is what they're going to show off all of those pieces on, which is their presentation. So it'll be a very exciting time for all of us to see what is this machine learning that we've all been hearing about look like when you're learning about it. If you have any questions, you can feel free to post them in the chat. I'm paying attention to that on the YouTube. If you have a fan favorite, you may also go ahead and vote for your fan favorite in that chat. Our students are going to be able to vote for their fan favorite in the student Discord. So if you're not a student of ours just yet, vote in the YouTube or on our Instagrams. We have Instagrams, LinkedIn, all of the socials, and you can see all of our information there. We will also have a social media campaign going on as well, where each team is going to have a nice little snippet so that they can put forward so everyone can get an elevator pitch of what they have been working on. All of our judges will spend the next week evaluating both the model, the use of the data, and the presentation. So it's out of 50 points total. So big, big points. And so I want to make sure that everyone knows that the results will be October 2nd. They will be on all of our socials for our students. They will also be on our Discord. If you're not a student of ours just yet, see how I keep saying that? Because you should probably be a student of ours. You really should. I recommend it personally. But they will also be in the Instagram or the LinkedIn's. We like to show those off pretty much anywhere we can. Thank you, OC, in the YouTube chats for noticing my joke and laughing at the putting in the work. I appreciate it. I work real hard on these jokes with my cat before we go live, so it's important. Keeps his spirits up. We're going to go ahead and move on now to our presentations. So our presentations, we have 3 teams. The first team that we have tonight is going to be double on genre, which, get it, entendre. Okay, guys, these are the jokes. Smiles aren't going to get you points, to quote the goat. Okay, double on genre is Michael Gleason, Michael Velasco, Isaiah Montoya. So let's welcome them. And who will be leading us through our very first ever machine learning code pudding project?
Hello, I'll be starting us off.
All right. I want everyone to notice too, I wore my very favorite data shirt just to be nerdy data people together.
Awesome. You ready for me
Isaiah,
to share
if
my
you're
screen?
ready, you're ready to go.
Oops. You can hear me, correct?
Yes, sir.
All right. Okay, well, let's kick it off. All right, this is our team. Our team name is Double on Genre. These are our members. First off, we'll just talk about the project overview. Our task was to create a machine learning model to predict the genre of a song using the audio features available through the Spotify app API. So our team started by thinking about who our users would be and what the use case for this model would be. We really imagined our user as Spotify themselves. And a couple of use cases we thought they would use for this model would be automating or suggesting genre tags for newly added songs to Spotify, and or automating genre-based playlist creation. From there, we wanted to define our scope and make sure we were staying in something that was manageable. So we decided to limit ourselves to 6 genre labels. And then just a little note I want to add here is we actually gathered subgenres into relative supergenres. I wanted to note that because I think it's something that makes our project unique and our data set unique. So considering our data set, we'll get into data gathering. The 6 labels we chose were rock, pop, hip hop, rap slash hip hop, classical, jazz, and other. And then other we just defined as any genre that was not in those first 5. So that basic overview did lead to a couple of limitations, and we came up with some elegant solutions. The first limitation was we ended up with duplicate tracks. This is because tracks in Spotify more often than not have multiple genre labels. So our solution was just a simple if statement. If this track ID has already been gathered and therefore labeled, we'll just ignore it and move on to the next. The next limitation we ran into was a limit of about 900 results per genre search. And this is where that unique solution came into play. What we did is we created a subgenre to supergenre dictionary, and a simplified version of that is right here, where you could see the supergenre labeled rock is actually made up of the subgenres rock, alternative rock, hard rock, similarly for pop. And this process actually gave us 3 benefits. One was that we were able to get a larger data set. We were able to pull 1,500 tracks per genre. It also gave us a more holistic range of features per our genre labels. So if you think about rock, instead of just pulling the features of the rock subgenre, we're pulling the features of rock, alt rock, and hard rock and grouping that all into the rock label. Then the flip side of that was also a benefit. That meant our other label was much more accurate because that meant that alt rock and hard rock, they're not being considered other anymore. So they're not blurring that line between what is rock and what is other. So with our data gathered, we can go ahead and move on to our data analysis.
All right, thank you for that, Izzy. So, as mentioned by Izzy, we have a balanced distribution across the 6 supergenres with 1,500 rows each. All of these have been checked for duplicates and missing values, and no data needed to be modified or removed. All right, next slide, please. Models usually work better with fewer variables. So we wanted to check which attributes may work better with our model. First, we visualized the attributes per genre using a violin plot to check their distribution and to check which attributes had clear differentiations per genre. Attributes that stand out here would be energy, loudness, and acousticness. All right, next slide. We then inspected them numerically by getting the group means to verify what we visually saw and to see any nuances that may be missed by the eye due to scale. All right, next slide. We then further ran this through a statistical test called ANOVA, or analysis of variance, where we measure the variance of the means among groups in relation to its variance within the group, represented by the F statistic. We also got the probability whether these groups are statistically the same, represented by the p-value, and we got p-values that were lower than the set alpha value of 0.05. So we reject the null hypothesis that there is no difference between the groups. All right, next slide. And lastly, we also looked at the correlation matrix of the attributes and saw that there are attributes that had high correlation coefficients, which, as we know, may lead to multi-collinearity. We see here that the three attributes that
Of
had
course.
high correlation coefficients greater than plus or minus 0.80 were namely energy, loudness, and acousticness. We then factor this in during training of the model, which will now be discussed by Michael.
Thank you, Mike. So as you can see here, the first thing we do with our data set, now that it's been prepared by Michael, we take 10% of it, 900 units, and we save that as a test data set to use at the end of our training. We take a few, if you look here on the right, you can see any of the track columns labeled object have been removed from the data set, and we fed the entire data set through the standard scaler, which optimized it for training parameters. Next slide, please. Here you can see the results of 8 different training sessions, each one with a different model. There's dummy model, logistic regression, decision tree, and light GBM, all 4 of which are mainly just simple machines. The dummy model was there for us as a sanity check to make sure that random chance is not better than our actual models. If we go to our next slide, I will actually address the multi-collinearity that Mike addressed. So I took our 2 best models, the cat boost model and the random forest model, and I retrained them using the data set with the columns that he specified removed, and they actually ended up performing worse than the original data set. So we went ahead and used the random forest for our final test, which is on the next slide. As you can see here, the confusion matrix you can see that diagonal as in every matrix you've seen so far. That's how accurate our model is. And the closer to 1 our scores are, the more accurate it is. And our models have been rigorously tested. The final part of our project was that we needed to write a function that took features from any given song. So we had our team member Isaiah. He wrote most of this get track features function. It searches the Spotify API for a song title and an artist name. And then at the bottom, you can see that the data gets scaled, and then we try to predict it with the test model, which in this case, with the song title and artist right there, it actually gave the genre other. Thank you very much.
I don't even have any words. So behind the scenes, for those of you watching, I'm just kind of like ogling over the coolness of this. So if you know anything about my story, I used to be a special ed teacher. And so anything having to do with data, visualization of data, and like interpreting data and creating models from that data just like blows my mind and makes me so giddy. So I'm very, very excited to see all of this work so far. Let's see. Michael, quick question. Michael Gleason, is Kimberly Gleason related to you? Because she's a fan.
That's my mother.
Good job, Mom. My mother also watches, but my mother likes to send me text messages to fix my hair. So at least your mom is just supporting your work, right? All right, let's talk about this project because it's so rad. I think let's try to start. Okay, let's try to start with like a great question for people who may be watching this and are trying to figure out like if this is some of the type of work that you're learning about how to do, right? So like what part of the program that you're in, which is data science, has that program helped you guys with prepare for this code putting, or have you been learning these visualizations and these, logarithmic functions and regressions and all of that? Feel free to answer anyone in this double on genre team. Yeah.
Yeah, I can speak to that.
Okay.
Yeah, I mean, to your questions, yes, generally. There's a couple different stages. You may have noticed on our first slide, we had different roles assigned to us, and so there's been different chapters throughout the program that apply to different aspects. Like the data engineering part I did, I believe was like Sprint 5 or something like that.
Okay.
Analysis is several different chapters, and then machine learning is also several different chapters. So yeah, it's a pretty good representation of a lot of the skills we learned in the program.
This is fascinating. And so maybe one of you guys could tell us, what is machine learning for people like my mom who are watching, who get the machine learning and AI confused, especially now, like in pop culture, right? I know there's a lot of things called a lot of things, but that's not what they really are. So maybe you guys could help us understand the difference between machine learning and what is Chat GPT.
I can take on that question.
Sure.
So machine learning is something like a weather app. So machine learning helps you to predict or forecast things, a future, based on the history it learned, based on it just predicts what will happen using statistics or kind of calculations, mathematical calculations. When it comes to AI, it's like it's a it tries to imitate, which tries to imitate like a human, so which tries to function like a human or above a human. So that is the difference.
Very cool. I really appreciate that. All right, Michael Gleason, I have a question for you. Can you explain maybe like a surprising pattern or relationship that your model discovered that in the music that maybe people don't realize, or something that you weren't expecting?
Something I did notice is actually the models tended to be able to choose get rap or jazz options more accurately than most of the other tracks or most of our other genres.
Do you have any hypothesis on why that might be occurring?
I actually, for rap and hip hop, one of the columns is actually speechiness. So any song with a high variability of that would easily fit under that category.
That is a really great point. Yeah. And in jazz, there's a lot of spoken word as well as kind of scat, which could be registering there.
Right.
Okay. And last question. Let's see. Who haven't I talked to? Michael Velasco. Look at you hiding in your dark layer. Okay. Let's talk about the model itself. So did your model go through and listen to all this music? Like, did it? I know you guys, so I know we gave you a database, but did you then have to have your model go through and like listen like a human would listen, or do you guys program it to do something different than what I would think of as listening to music?
Right. So what happened was the data was gathered through the API, giving us numerical values, numerical features for these
Okay.
tracks. So the model did not listen to the tracks, had values coming from Spotify themselves as to what the speechiness is for this track, what the acousticness of this track is, and converting those into numbers and identifying those patterns is what the model used. So if you notice when we did the visualization with the um, uh, violin plots, you're going to see there that in terms of the speechiness, if you look at the plot for rap and hip hop, it's the one that had the most. So it's just more of recognizing which tracks fit into those patterns that we see in the data.
So I guess in this case then, and this is, I guess, something for all of us who don't work with this to know is like, I know in when I'm making SQL databases, right? Garbage in, garbage out. So in a lot of cases, for what you guys are showing us tonight, it's the same, right? If you have good data with all of those kind of nodes and bits coming in from Spotify, great, then you guys have a lot to work with. But if you have just kind of where they're like, yeah, here's a song, it has beats per minute, and that's all you get, then it makes it quite a bit more difficult. Poor OC, he's over here in Sprint Zero, he or she, I should say, and doesn't know anything we're talking about. And I would say, stick with it. You'll get there. And then you can rewatch this when you're further along, and then you'll be amazed. Okay, so anything else from Double on Genre? Any last little bits would you gents like to add? If not, we're going to move on to our next group.
I think we're good.
All right. Okay, that is Double on Genre, and I just am so excited. That was amazing to see all of those models. I can't wait to see what this next group is going to show us as well. I can see in the chat they already have a couple of fans. When this team is Groove Guardians. So the Groove Guardians are Tirso Paneke, Leif Mathis, Ellen Montes, and Michael Twersky. Who will be speaking to start for Groove Guardian?
It will be me.
Fantastic. Okay. Carmen is rooting for you at home.
Thank you, thank you. Okay, hey y'all, I'm Elise, and my team and I are called the Groove Guardians. You can click onto the next slide for me, please. Yes, and then another one. Perfect. Now you can see our lovely faces from left to right. You can see me, and then you can see my next peer, Alan, then Mike, and then Tirso. And while we're all from different regional time zones, we work pretty diligently on our amazing project in order to showcase today. So jumping right in, we're going to start with our introduction, then get a glimpse of our EDA and visuals, then assess our machine learning process and its pros and cons, and then lastly, test our wonderful prediction function, and then close out with our conclusion. So next slide. So yeah, for starters, I want to explain that our model was developed based on our very large, correction. It was based off a very large pre-made Spotify Kaggle dataset where there were 114 unique genres, and each genre had 1,000 rows of songs. And next, Alan can share more about this with us and their audio features via the EDA.
Thank you, Elise. So for the exploratory data analysis, we noticed there was a relationship between the music elements and the genre. For example, in the EDM and R&B, we noticed that there was high tempos with bright keys. Also for hip hop and pop, they have danceable beats, but just pop varies widely in the tempo. In terms of explicitness, EDM and R&B were mostly non-explicit, while hip hop was more explicit. Rock had a mixture of explicit and non-explicit, and pop music was generally had like a cleaner image. Next slide, please. And if you hit play, please. So we created a sunburst chart using Plotly. This is for the rock genre. The center of the sunburst chart would be the explicitness, which would be in red for explicit and blue for non-explicit. The second ring is the keys of the song, and the outer ring is the tempo of the song. So the sunburst chart creates a great visual to display the relationship between the different elements. In this case, it's the explicitness, the keys, and the tempo. Next slide, please. And we also created a scatter plot on Plotly. And here, as you can see, we use the energy as an x-axis and the loudness as a y-axis. You can see that as the energy increases, the loudness increases in the songs. This is for all the genres, so you can see on the right. So it shows a positive correlation between those two elements. And what we liked about this scatter plot is that you could the interactiveness, that you could just click the genres that you'd like, and you can compare them one with the other. And then now I'm going to hand it over to Mike. to explain the machine learning aspect of it.
Thanks so much. So, our approach was pretty standard as far as the machine learning. Our data set was from Kaggle. It was about 114 genres. They all had 1,000 examples. Each song had only one genre. So we did the typical pipeline. Genre was our target. We split the data three ways. We did label encoding on the genre. So basically, for those of you who aren't technical out there, it turns the genre names like rock, rap, hip hop into basically like numerical values that can be fed into the model. And we saw this problem, as the earlier group did, as something called a multi-classification problem. So it was classification, it just wasn't binary. It wasn't just one of two. So we then scaled the features, and what that basically means is the features inside the model are of all different sort of ranges. So it brings them all into like similar ranges. So what I'm going to do now is in the interest of time, I'm going to hand it over to Tirsu. He's going to go over some of the actual modeling that was done. Tirsu, take it away.
Thank you. I'm gonna show now. I hope you can see the work we did with the models. So we split the data as said, we scale it using our standard scaler so that all features have more similar ranges, since there are some of them like the duration that went crazy up. And we started training a logistic regression model. It yielded low values in accuracy, but as our bedrock was okay. Then tried a random forest. That one did a little bit better with some overfitting, but still did pretty good. We also had to comment some out to be able to rerun the code that this would be the grid search to tune the hyperparameters of the model. And that improved by a little bit the accuracy of the model. Then we tried an XG boost classifier, and that one also did sort of well, not as good as the random forest, but it also did pretty good. We also tried a multi-layer perceptron from scikit-learn, and that was one of our best models. It classified really good. Also did a support vector classifier. We tried doing a light VM, but most of the times it crashes around because it was way too heavy and computational resources was scarce. So we had to switch into an SVC. And then to combine all the models, we used a soft voting classifier, and that one did the best results overall, as you can see over here. Now Mike is gonna talk to you a little bit about the function we use to retrieve the data from the Spotify API.
Thanks, Tirsu. So basically, the final model we went with was the soft voting classifier, which is basically in a nutshell, takes the average takes the average genre predictions of the other models combined. So what we did was we then used the Spotify API in the function to extract these audio features, which matched the features in our model. And so we turned that data into a data frame in the next line, or as part of the function, we turned that data into a data frame. And then we were able to basically scale that data frame similar to the way we scaled the features and then feed that back into the soft voting classifier model. So before we finish, Tiffany, would you like to give us a song that we can feed into the predictor to see what it predicts? And again, I will say before, just as a quick caveat, our F1 score was about 31%, But if you think about it, 1 out of 114 genres at random would be like 0.0087%. So it's much better than random, but it's not perfect. So if you want to feed us a song, we'll see what it gives us.
Okay, we'll go for it. Shake It Off.
Okay, Shake It Off. So we're turning
Look
it
at it
into,
go.
is it dance?
I mean, it's pop, it's dance. Yeah, it's Taylor
Okay,
Swift.
it's close. It's close. All right.
I'd say that's close. You definitely danced. It is dance worthy.
Okay, so to finish, I know we're over time. The soft voting classifier was what we would go with, but it did have the highest cost of compute and the longest time, by far the longest time to operate. So it might be worth going with a slightly less of a performance to save the costs, the computation overall, and things like that. And that's it. Thanks a lot. We appreciate it.
Oh, this is wonderful. Real quick, is it Tirsu or Tirso?
Tirso.
Tirso. Okay, I wanted to make sure I'm getting, it's my personal goal to get everyone's name right. This has been awesome. I love this. Thank you guys so much for showing us to the code that you have been writing. Let's start with this visualization that you showed us, the video of this, which one? The sunburst one. Can you maybe walk us through, someone on the team, walk us through how that visualization helps us understand your modeled decision-making process for classifying those songs?
I can definitely take a jab at it. So with
Yeah.
the audio features, it was very interesting to see it kind of cluster, or I guess group all the elements for all those songs. And we did attempt this on similar to the first group where we did group them all, where it's like it took all sub genre categories. So if it's like pop, it would take K-pop, J-pop, and all the other variations, and it would group it together, and it would see because we base it off of the popularity scale. But it would take them all, and then it would sort of rate it in its major classification from explicitness, whether if it was, let's say if there's a lot more adult language being expressed versus something a lot more wholesome, or maybe the song was actually in reality radio edit. So that was something we also kept in mind as well. So like, let's say with your song, let's say Shake It Off, it had some, let's say it had certain vulgarness into it, but let's say, they had the adult, sorry, the radio edit version of it and was able to, bleep out certain words. So that was more
Okay.
accessible for a lot of people. But yeah, so it took that
That
and
would
then
increase the popularity, right?
yes, right. So then it would take it and then expand upon the keys that it was played in, and then the tempo itself. So it it's very interesting to see it unfold essentially. So
Yeah.
yeah.
So then here's another question. I saw that I love that you showed us your notebook. Thank you so much, because that's one of my favorite, definitely one of my favorite parts is to see kind of the behind the scenes, right? And so I noticed that you guys are using the Google Collab notebooks instead of like a local based Jupyter notebook. And so I wanted to know, how was the collaboration process in this platform for you guys, especially being across all those time zones? Were there any maybe unique advantages or challenges you guys had to work through as a team?
So I'll take that one really quick. We actually, I used the local Jupyter Notebook on an Anaconda environment, but Tirsu likes the Google Colab, so he used that. And then we just used GitHub for version control. We didn't actually use Colab in that sense.
Okay. That's fantastic to know, because I know that is sometimes it's that piece where for people who are earlier on in the sprints and they are not sure they want to join one of the code jams or the code puddings, is because they're worried they have to learn another collaboration tool. But it sounds like you guys are already leveraging the ones that are kind of the most familiar to many of us already. That's awesome. All right, so in the YouTube chat, it's banging over there. So when you go back and look later, make sure you do. We've got a go, Elise from M, and then Carmen is shouting out, "Well done, Alan," And then Anusha also doing a great job. Anusha, hi. I think we've seen each other before. Okay, so let's go ahead and give it up one more time for the Groove Guardians. We are going to move on now to our last team of the evening, which is Tune Tensor. Tune Tensor. So that team consists of Eric William McDougall. Ooh, got your full name here. Sorry, Mr. McDougall. That is very proper. Zoe Espinoza, and then Aya Govind Raj.
Thank you.
And then before you guys begin, just a thought for everyone. One of the questions is for voting purposes around like who is the favorite. And I know Daniel, you're on here too, so perhaps this might be a question for you. The viewers would like to know who is the target audience for these visualizations and this data breakdown.
That's a good question. Yeah, because you can kind of perceive, or you can judge the understandable nature of a visual based on who it's meant for. So I would say, so far we'll say that you can judge these based on perhaps not being the target audience not being somebody who's completely non-technical, but somebody who is minorly technical, unfamiliar with the project. So somebody who can understand some basic visualization, but is not intimately familiar with your project. They're coming as an outsider. The visualization should be clear and explained to them quickly, easily, and clearly, like how or what you found in your data.
That is fantastic. Thank you. Thank you so much, Aya, for letting us cut in line there. Okay, this is Tune Tensor, and then you may take it away. The stage is yours.
Thank you. Let me share my screen. Are you able to see my screen?
Yes, ma'am.
Perfect. Okay, give me 1 second. Okay, so our team is Tune Tensor, and we developed a multi-class prediction model for genre prediction. So this team, let me introduce our team. It's Zoe, who is the music coordinator. Like for a music, how a coordinator is important, like that. Zoe is important for our team. She did the Spotify, setting up the Spotify API, GitHub setup, and coming up with a baseline model. And Eric is the artist, it's like an artist for an album, who did all the data set building, EDA, and refining the model. And I am myself, I'm like a sound engineer for an album. So I did visualizations and feature engineering stuff. Okay. So let me get on to the introduction part. So before we jump into and start working on the model, what is the real use case of this model? So why do we need to predict music genres? So the first reason this music genres would be helpful is personalizing the user experiences with better recommendations. So based on what a person prefers, based on that, which genre a person prefers, then it will be easy if we have a model like that to suggest the other albums in the same genre, then it will be easy for them. So it's just to build recommendation engines. And another thing is it's an interesting analytics, because entertainment field is the analytics in the scope of entertainment industry is growing field. So doing a project such that would definitely greatly help with the entertainment industry.
So the goal was obviously to predict the genre of a song, given the audio features that we get from the Spotify API. Some people have already spoken about how they used a Kaggle data set for that. We were getting our data from the Spotify API and then hosting it in a kind of local data set that we could have access to. So the features that we were working with were tempo, energy, danceability, valence. Each genre had about a sample of 75 tracks. And again, the Spotify API was how we collected that data. So we used a host of different models, and Zoe did half of them, and I did the other. They included random forest, support vector machine, gradient boost, cap boost, k-nearest neighbors. There was logistic regression and a dummy classifier as well. The target variable being the music genre. We had 10 genres that we were working with, and naturally a dummy classifier would be right 10% of the time in predictions. Next slide, please. So the model that we found performed the best was the cat boost classifier. It had an overall accuracy of 57%, which again, when the dummy classifier would be about 10%, is pretty good. We also included several other metrics or recorded them from the models as we were training and testing them, including the F1 score and the Awk score. And Cat Boost performed the best in F1 and Awk as well, with Awk I think being like 0.91%. The genre that was most easily recognizable by the models were classical and gospel. The genre that had the lowest accuracy scores was reggae.
So having explained, what are our models we tried and, the best results, I also like to share the challenges we face when developing this model. The first thing is there is a limit on the Spotify API calls, which took a little bit of time for us to build the data set. And secondly, when we started building this model, we initially took a whole lot of genres, and we got an accuracy was around only 25%. And to improve the accuracy, what we did is when we try to figure out why this accuracy is low, and when we explored, we found that the number of genres is causing the less number of accuracy. So we reduced, scale down it to 20 genres, with which we were able to achieve 57% of accuracy, which is definitely much better than the baseline or dummy model. So coming to the key insights, so we did the exploratory data analysis, and we found that the importance of danceability and energy in the genre prediction, which I will go and show you in this heat map. So as you see, the danceability, the right corner on the bottom is the genre. So if you can see here, the energy, the loudness are highly correlated to this genre prediction. And also the acousticness and the instrumentalization, those are negative, the lower values really helped with the genre prediction. And other insights we found is that even though with a smaller set of tracks per genre and with the limited audio features, we'd say definitely the model predicted. With that limited data set, that a model really predicted well. And the niche genres, like what Eric explained, like the classical and gospel, are best predicted by the model. Okay, talking about that and thinking on the next steps, how we can improve this model. If we have much more time, we could have done exploring additional features like lyrics or metadata, and then we can also refine the model by fine-tuning the hyperparameters using ensemble techniques, and then the genre subcategories might have helped to further accurately predict the model. And having more data would much more help with the model prediction. That's all with our code jam work, and we are welcome for any questions.
Oh, that was fantastic. I'm so glad you guys shared some of the challenges, because I think, especially when mentioning those API calls, we all kind of forget, like, API calls, they're free to a certain point. And when you're processing a lot for a lot of this, like, model building, right? Machine learning can take multiple API calls. And so that could slow your process down, huh? All right, let's ask some questions here. I think my first question is what, and this can be for either of you, which is your favorite part that you created on this project?
Eric, if you are willing, you can take on, or I will take it. Which one?
Why don't you
Okay.
start and then Eric can jump in on his own.
Sounds good. The favorite part of this work, I liked I tried with the future engineering stuff. So two things I tried. One is weighted score. So because I found the popularity of this song is based on how many minutes it is played. Like I know how much number of minutes it's played, and I could find, like, with that I came up with the interesting weighted score stuff, and also I did some sentiment polarity, but both of these things, when we plugged into a model, it didn't help with the prediction. So that's a nice finding, but anyway, it's
Very
good that we
cool.
tried different, like understanding this music and learning these key factors is really interesting thing in this project.
Very cool. Eric, what are your favorite parts?
My favorite part was also like the thing that was causing me the most headaches for the time period, which was the max retry error from the API calls.
Oh,
So Zoe gave us like a really good like foundation. She got all the API code done in like a day. Um, but it had a limitation in that we were doing like 20 genres. We were doing like 25 tracks per genre, putting it into a data frame and then pushing that through the machine learning models.
yeah.
That was horrible. Just because like it limited us to about like 250 tracks. And if
Which
you
sounds like a lot if you're just a person, but for a machine, that's like nothing,
yeah,
right?
it's nothing. It's nothing. But for um so like I didn't like set out with like the design of okay, we need to host this locally to have this work like to gather like thousands and thousands of tracks. I didn't set out like that. But it just began like evolving slowly where I would after every API call I would dump it into a data set that we were hosting locally and that we put on GitHub, and then check for duplicates, remove duplicates, and update the data set. So I suspect it's given me some practice in having to like figure out how to get around API limitations. Um, but like I enjoyed that weirdly and perversely.
Well, I'm glad to hear you enjoyed it. I mean, that's the key, right? Is to find find joy in the miserable parts, so to speak. All right, so this is a question that I'm going to open up for everybody. Um, Tune 10, as I do, while everyone gets their cameras back on, I'm going to go over again. Tune Tensor was Eric McDougall, Zoe Espinosa, and Aya Govindaraj. So there's a question in the YouTube chat from Alba, and I thought it was a good question to bring up to everybody on here. So I'll ask the question, what sprint do you have to be in for a code jam? And so I would say for a code jam or a code pudding, in data science, you need to be about sprint 10. Okay, so you need to be done with sprint 10. But it got me thinking, this is the first one we've had where we've had not just a visualization of data, but like actually building that machine learning model. And so I wanted to ask all of you about your experience and kind of like, do you have any advice for any students coming up that want to join the next round? Do you want to maybe share a tip you learned? Um, a way you learned to suffer through the misery? Any advice or tips would be awesome, because I think there's a lot of people who are in the data science program that are looking to join the next round for our ML code putting.
I mean, I would say you should be like up through sprint like I think 11 or 12 before you get to like the computer vision and NLP sprints. And then I think you should like it's really good experience looking up the documentation, I think, because we hadn't done specifically multi-class classification, so that was new. And then yes, you learn a little bit more about some of the parameters for the algorithms that we hadn't used before. And then obviously the Spotify API and the function that was partly new. I hadn't used Spotify before, so I think it's just a comfortable learning how to read some of the documentation stuff.
Okay, that's a great one. Don't make me do my teacher wait time, people.
I have you just said advice, right? You're looking for advice?
Yeah, advice,
I mean,
tips, whatever you got. Ice cream flavors at this point.
yeah, I mean, generally, I would just say remember to take breaks, use the Pomodoro technique. That's always a
Ooh.
thing I struggle with because you're in the problem solving state of mind. I get in that, and it's like I don't want to walk away till I have the problem solved. But some of these problems take hours to solve, so you gotta be careful.
Yeah, 6 hours later, you're still sitting there. Yeah, that's a good one. All right, maybe one more before we go. I will start calling on you people. I was a teacher. Oh, Elise. See, now you done lost.
I have a thought.
Oh, Elise, you're going to get saved by Aya.
Thank you.
So-
Teamwork makes the dream work.
It's a personal opinion from me. It's like
No, I think that's
chicken and-
great.
it's like a chicken and egg question. So would you rather learn by doing, or would you learn and then do? Either do and learn or learn and do. So it depends on the motivation and interest and the curiosity the person has. But
Okay.
to begin with, to set that baseline, I would suggest like they should at least know how to build a model.
Yeah. Yeah. And there's a Anusha in the chat put that sometimes we all work best under pressure. And so it sounds like this is definitely one of those times where you can take all the things you've been learning and really put it to practice and
Okay.
come out learning a lot.
I have one more thing since I was
Yeah.
picked by random by popcorn. But I'll also say reverse engineering is also another approach to consider with the whole Pomodoro method and documentation, because sometimes we kind of get stuck and fixated on one particular thing that's not working, but also, just taking a step back, maybe take a break, and then also maybe look at it with fresh eyes and then bring in a new
Get that
perspective,
big
either from someone
picture.
else. Yeah, get that big picture to see like, okay, maybe I was a little caught up on this, and then I should probably focus on this that could probably get me a better a better result in the end. So yeah.
Oh, I'm so glad that you said that. It's a really great point because, sometimes we get caught in the little details and more focused on making it work rather than, is this the way that it could work, or are there other options, right? And we all know, having learned through all of these different sprints, that there are hundreds of different ways to come at a problem.
Yes.
All right. Well, that is going to conclude our code putting for the evening. So from all of us here at TripleTen and the code putting teams that you see here, thank you guys all so much for coming on and doing your presentation. It takes a lot of courage, and I very, very much appreciate it. And seeing what you guys have been able to do in 4 days is still very masterful and impressive. I want to thank all of you at home and YouTube for watching us. Thank you so much for your comments. You can vote in the YouTube chat where you guys have been so lovely. You can vote in there for your favorite project. And if you are a student of ours, you can vote in the Discord channel. So please feel free to vote in either of those two places. If you are not on the YouTube and you are not on the Discord, Instagram is a good one, or other social. All right, results and winners are going to be announced October 2nd in the Discord and on all of our social media platforms. So make sure you check in there. I want to say a special thanks to everyone who helped organize this code pudding. Daniel, Camilo, Natasha, Alisa, Olivia, Ulia, Daniela, nope, Danila, Danila, Nadia, and my cat Star Fate. Thank you again for all the participants and being our first machine learning code pudding. This has been so much fun. I really appreciate it. Again, if you are interested in joining a code pudding or a code jam, you can reach out to your success manager if you're a student of ours. And if you're not a student of ours yet, what are you waiting for? Hello, we're having a blast. My name is Tiffany Hull. You can find me at Tiffany Codes on Instagram, and you can find my cat probably writing more jokes for next time on the table in the kitchen. Thank you guys so much for watching and have a great evening.
Thank you.
Bye-bye.
Thank you.